Taking the time to view this video. This is part of a series talking about cyber resiliency and backups. Specifically, in this video, we're going to talk about securing your backup infrastructure. We've kind of simplified it by narrowing down in 10 ways. This is specific to Spectrum Protect, although certainly a lot of these concepts can be taken to other backup products. When you look at cyber resiliency and the risks involved that are necessitating us to be much more resilient to cyber attacks, there's a lot of very interesting facts out there. One of the ones that really hits home for me is that the World Economic Forum, when they go out there and look at the global risks and ranking them, cyber attacks is number 3. This can be attacks against businesses, individuals, but also government agencies, and it's more than just ransomware. It's more than just insider attacks. There's organized crime, state-sponsored attacks. This is in the context of risks including natural disasters. So this is incredibly important, and the view of the world at large is that this is something that's going to be critical to take care of and to be able to deal with. You'll see this in organizations where now there's chief security officers, and there's people reporting to Mahogany Row that say, I need you to help figure out end to end how we deal with these cyber attacks. The risks as far as a monetary value is also very big. I haven't seen things like this since 9/11, where people were looking at the impact to an organization over time to this amount of downtime. And when you look at this, these organized criminals are attacking financials, they're attacking hospitals. So the risk is obviously much more than just dollars and cents, but you also get the idea that every organization is at risk for this. 1 in 4 is going to have some sort of attack, whether it's an insider, a small ransomware, or something that really can cripple an organization. If you look at some of the Maersk, Crane, Kiev, all this kind of stuff, you're starting to see all these different people being attacked. It's not just a couple of doctors. It's everybody out there being impacted, and we all are at risk, and we all have to start taking this into account. If you look at the information from the Verizon report, and some of the information I've already shared came from IBM reports as well, some very interesting things. If you look at who's behind the breaches, 70% is from outsiders, but 34% have involved internal actors. But you also see things like disgruntled employees. And we'll talk about how that impacts how you do security. A lot of this presentation is about how do I secure my infrastructure so that one individual can't destroy all the primary and backup copies of data. We also look at the different tactics being utilized. So 28% involve malware, but even more are social attacks. This is seeing an email that someone says, I need to click this. And even in IBM, where I work, we have these internal tests, and periodically we'll refresh workstations, for example. So you send out a note, say, hey, you're on the list for a workstation refresh, click here, just to see how many people will click that link that goes nowhere within IBM. So no one is above it. Everyone has to start doing penetration testing and education. If we look at other commonalities, these aren't just turnaround within a week. 50% took months or longer. A deep infiltrator has gone in and started doing the work, or the ransomware has been out there doing corruption for long periods of time. What does this mean to backups? Well, it may mean that your backups, even if before the encryption event, may have the Trojan, the malware built into it. So if you do a recovery, you may need to go out there and do a recovery in a sandbox and then apply a patch before you expose that machine to the network again. 32% of breaches involve phishing. That goes back to the social attacks. If we look and try to have a common way of describing what we're doing, certainly the NIST framework, this circular step by step but forever repeating process, talks about how to best protect yourself against cyber attacks. Now, where we're going to focus is in the protect and recover, but certainly your data protection solutions do have options on detecting the impact of cyber attack. Let's go ahead and look at the top 10. What we're going to talk about is hardening the servers. How do we go ahead and protect the servers against ransomware? How do we secure different things, whether it's the communication pathways, the host, how do we administer the protect servers and the protect clients? And basically, none of this is going to be shocking to anybody. It's good security practices put in the context of this software. If we look at some of the mistakes we make, I've gone in and done many Spectrum Protect or TSM or even ADSM health checks. A lot of times you find these same practices where everyone uses the same admin account. The admin accounts have a well-known password and they don't change that password very often. The firewall's been turned off on the backup engines as well as other security layers. The client node password initially is the same on all servers or is something well known like the host name of the machine. That may not be that big an issue long term, but we'll talk about that. Communication sessions are not encrypted, and we've made changes in the product which makes that harder to be true anymore. And we don't do a lot of testing. We've got different versions of software which have different levels of fixes. Flashes, as far as communication from us, from IBM, as far as important fixes to be applied, are not being signed up for or not received. Another big issue with Protect. Protect is a very chatty product. It tells you a lot of information. And if you're not on top of it, you can hide critical information from the day-to-day stuff that you should be taking care of. We also have problems where people have different client option sets in the local files, so no one's exactly certain what the client options are being used. And testing and recovery is done by an actual recovery, so there's no official or formal testing protocol. And DR testing, most organizations have DR tests, and that's great, but sometimes it stops the day-to-day DR protection, and you don't want that. So I want that DR protection to run every day. Implied here in some of these bad practices is even if I've got good administrative accounts, I may have access to both the primary and secondary copies of backups. And that can be dangerous. If you want to protect against insider attacks, don't give every person unlimited access to all the data. Quick recap of the Spectrum Protect security model. Every client node has its own password. Every client node can access its data, but no one else can unless you permit it explicitly. All Spectrum Protect administrators have their own password. An administrator has no authority other than that's been granted. So if I create an admin, by default it's read-only. We used to call it analyst. And unless I give them more access, they don't. Even if I give them a higher level of access, you can limit the scope to specific domains or storage pools and things of that nature. And you can also enforce complex password rules. So you can have external LDAP or AD say, well, I need to have this length of a password and this number of special characters and numbers and alphabetic numbers or characters and case rules. Number one, we want to harden the Spectrum Protect server. To my mind, this is all about putting up your shields and using a cloaking device. I want to have as much protection as possible. Does that just mean enabling the firewall rules on the hosts? Certainly that's a first step, but it doesn't have to be limited to that. Many network admins will say, I want you to enable those on the host, but I want you to tell me which ports, and I'll start controlling this in the network. And I want to start monitoring things. Similarly, you can say not only the firewall can limit to ports, but as well as what addresses and in which direction the communication can take place. Part of putting up, like I said, the cloaking device means don't share stuff from your Protect server. And once again, this is not anything that is going to be a surprise. These are standard hardening rules. One of the interesting things is that there are components of Linux or AIX that say, I'm not going to let you modify this server. Now, you have to turn that off when you install software. Now, what our manual does not explicitly remind you of is you can turn it on afterwards. So even if you have to turn off SE Linux or trusted execution, please remember to re-enable it. You will have to turn it off when you do updates of the software, but the whole point of that is don't allow changes except those we expect. So definitely harden these servers as much as possible. Now, can I protect against ransomware specifically? Many modern data protection engines, and Spectrum Protect, and it's true, use disk-based components, whether that's the database, whether that's the file system containing disk-based storage pools. We support disk-based storage pools with dedupe and compression and encryption at rest, but this is disk-based. So once you've hardened the infrastructure so that malware is not going to attack the server, can you do anything else? Well, you can exploit snapshots. This can be at the file system or the disk snapshot level. You don't have to do this or keep many versions, depending on just enough that you have time to react. And typically this can't be managed by the backup engine because it's protecting the backup engine. So these will typically be crash consistent recoveries, but remember, Spectrum Protect has a database and it's got a transaction log, so it's resilient to crash consistent backups. We'll talk about other components like parameters like the reuse delay later that make it so that even if you roll back a database or restore from a database backup, the data is still going to be in a state that is consistent in the storage pools. You can also do this with critical clients. I've got a critical client that I need to bring back rapidly, and my only backup is a traditional streaming backup. Perhaps you can use disk-based snapshots to augment that, or so I can have very fast recovery of these large file systems. We can also utilize different types of storage. If you look at storage and say, how do I go out beyond just disk-based, whether it's virtual tape library, which may or may not have virtual cells, where it's physical tape, where I have true air gap and optionally encryption and even immutability. Physical tape is one of the best ways of getting all these features at once. And I can make a copy of the database and a copy of the disk storage pool. You can also exploit object storage. Now, many people, you'll say, object storage, is it air gapped? Well, it's connected. No, but it's not a file system. It's not being attacked by ransomware. So it's a really good thing. You can go out there and say, I want to store a copy or long-term retained data or my replica on object storage, whether it's on premises or in the cloud. And some of these object storage also have immutability functions. So this really can fit in well with your hardening of your storage pools, if you wish, kind of methodology. What else can you do to be able to detect ransomware? Starting at 815, if you have backups that increase in volume beyond the norm, you can get a security alert. If you're using a dedupe storage pool and all of a sudden the data is not deduping as well because it's encrypted, encryption takes a unique key and makes the data unique. It's not going to encrypt as well, so you can get those alerts. As we mentioned earlier, there's a parameter called reuse delay, which basically says don't reuse empty space for X number of days. So if you have to revert to a previous database backup or to a previous snapshot, that's a really good way to go out and make sure that the data, even if it's been expired, now if my database has been reverted to an earlier point in time, that will still be there, and so the space will not have been reused. Is your backup infrastructure your first line of defense against protection? No, remember, we're talking recovery now. This is a tool used to go out there. This has got to be part of a much stronger security and education and patching kind of methodology. Here's a screen snapshot of our security alerts. And I'm really very proud of this. Do plan to keep enhancing this. This is one of the areas where we really want to continue to be state of the art. Third thing you do is secure your communication pathways. This basically means use modern SSL. Now, starting in 812 and 718, we made it where you could not turn off SSL for command and control kind of things and authentication. It won't turn on data encryption of the backup stream, but all the communications, all the components that basically say, which prevents us from having these man-in-the-middle and other attacks where people can go ahead and bring the infrastructure down or corrupt the backups. So this is a big enhancement. Other things is talked about using the firewall. You can even separate backup and administrative ports if you want to have that level of control. If you have a DMZ, Spectrum Protect works well from DMZ. but you probably want to isolate that from other functions of the Protect infrastructure, although most people still manage it with the same OC. And you can say, if I have clients outside the DMZ, you can set it so the clients cannot initiate the session. You have to tell the Protect server the IP address of the target, but Protect server can be the one to initiate the session. We look at the enhancements at 8.1.2 and 7.1.8. It uses the global or security kit or GS kit, the state-of-the-art platform that IBM has for across all of our software. So obviously IBM has software in many different areas and different functions, and so this is one of the reasons we really put a lot of effort in to making an extremely robust set of capabilities, and we don't make it available outside of our software, but it's available universally within our software products. Number 4, secure Spectrum Protect administration. Having good security hygiene. Don't share administrative accounts. Don't have the password be well known by a large number of people. One of the things that you can also do is, for my day-to-day work, I can have a Dan Thompson account. But if I need something, Dan Thompson super user or something as equivalent, I can have one that has more access, and that can be audited. You can even have that password managed by someone else. So I may need to go to a second person and say, I need to use Dan Thompson super user. Can you reset the password for me? And if Dan Thompson, that person who does that has a higher level of authority, so that may be a manager or just maybe a member of the security team. Depends on how your organization is laid out. You can also go through there, and if you do scripting or any kind of automation, have dedicated accounts. This can be tough if I don't want to just have a script robot account for everything. Make it a little more granular. If you do use local scripts, store them in a secure location. Part of the 8.1.2 and 7.1.8 enhancements was to store passwords in a password vault, so we enhanced it there. So as long as you store the scripts in a secure location, you should be well off. If you need one-time setup scripts, you can go ahead and unlock or change the password of the account and then undo it. This is very common if you have scripts that build Protect servers, for example, and you don't want to have that sitting out there at all times. So definitely any of these, report upon your activity, particularly for these high-level security accounts. Use complex password rules. If I use object storage, this is all part of, don't give one individual the keys to everything. You can store those object storage credentials differently. I can have the accounts for primary and secondary servers be separate. I'm going to step out of PowerPoint and kind of show you what that looks like briefly. I have 2 servers, and I have an account called primary root on the hub server. That account exists on the spoke server, but does not have system level security. Everything looks normal. I can do what I want. If I go over here and on my secondary server, I can look at nodes. Let's say I want to start deleting the data for this Windows 2012 file server, which is cleverly named Windows 2012 file. L just the number. You sure you want to do that? It says I can't do that. On the primary, but I have system level account, so I can destroy node. I can remove its REPL node status. I can delete its file spaces in its node. As you can see here, I can't even start that process on the secondary server. Now, this is just one example, but you can secure your infrastructure as well as the different parts of the storage. If you're using object storage, for example, I can make sure that one person can't go out there and destroy everything. And obviously, one of the big problems that we have with accounts in general across IT is as people leave, we don't decommission their accounts. So make sure you keep up with that. How do we secure to protect clients? Do not use simple, well-known passwords. Now, remember, once the password expires, TSM or Spectrum Protect is going to generate a new password. So this is a limited time, but also create random passwords, audit for password exceptions. There's a node try to connect. This is one of those things now with 8.1.2 and 7.1.8. If someone tries to connect without the certificate, this will be logged. So keep an eye out for those kind of messages. We do have web clients. The old one was disabled, but a new one was introduced in 8.1.7. You can increase the logging on client activities on both the server and the client side. You can use the client management service, which allows you to see logs from the operations center for Windows and Linux clients. And one of the big things is stay on top of miscellaneous warnings. We get a lot of missed files warnings out there that can be handled with exclude includes. When you install the client without an options file, for example, it'll generate an include exclude list. That's the standard default. So this can go a long way. I see a lot of customers that they try to do that manually, and that's fine, but they'll get warnings about unable to back up the registry as a file, and every single Windows client shows that. That says, you should be excluding those kind of things because you're just going to have a flood of messages that are really going to hide things. Number 6, this is possibly the most important thing in this entire presentation. If you look at ransomware in general and say, what one thing, if one organization took one rule and did this, what would prevent ransomware in so many cases? And that's applying the correct fixes. Most exploitations are known. And yes, it's a constant race to keep up on different zero-day attacks, for example, and different overrun attacks. The criminals and script kiddies find them. So we want to go out there and keep current on the OSs, keep current on all application software, including Spectrum Protect. So make sure you're getting alerts. And you'll see it. Occasionally I get a bunch of scary messages and say, Spectrum Protect, if you haven't applied the latest patch, you're exposed to this, whether it's in the Java or WebSphere stacks or different things. So always keep up with this fact. We try to be very open and fix things proactively and send alerts, but you've got to sign up for those. Follow strong testing and currency policies. We're starting to get into things that are moving away from security and just moving into good ITIL processes or PCI processes. Have strong testing. Make sure you have a rule that I don't let software get very much out of date, whether it's a flash or not. Have a rule that says I don't apply software that's less than X number of days or weeks old until it's gone through some kind of testing. You can also expand out to other ITIL processes. You can have enterprise scheduling and software distribution, problem management with feedback loops to say, okay, I had a problem, you apply this patch, did you certify that the problem went away, did we document this, so that we know that it's solved, and if someone else sees that problem in the organization, what the fix is. So this is getting very much to the core of how IT itself is being run. How do I validate my service? This is another part of good best practice in an organization. How do I validate my service? And that involves testing, and both of the primary and DR copies. Now you start seeing organizations have DR testing procedures. Most organizations have DR testing, but it may not go down to restore a database on my primary site, restore of different flavors and different sizes from different storage pools, restore a file server to see how long it will take to make sure I haven't overtuned my infrastructure for cost efficiency but hurt performance. How do we know these things? And certainly you can get an idea if you look at backups, how well you can do restores, but there's really no better proof than doing a reasonable amount of testing outside of just running restores. The rest of this is how do we make everything easier to manage? Certainly if you look at the IBM reference architectures of Spectrum Protect or Protect Plus blueprints, those really go a long way to helping you adopt a cookie cutter kind of approach to managing things. I've seen some really clever naming conventions that took sort of a Rosetta Stone or a decoder ring to figure out what they were trying to say. So maybe standardizing a naming convention that works across servers, as well as you can use enterprise management to say I have the same policy domains and things like that across all my servers, and not have one of the same name but have different rules, so it makes things harder to manage. Certainly monitor your workloads and make sure that everything's working as intended. Also leave a spare amount of workload capabilities. I used to have this big problem with people using tape, and they would just really design their tape infrastructure for day-to-day workloads, and they did not account for ad hoc spikes or did not account for a tape drive going offline. So remember, this data protection service, you don't build it for backup. You build it for recovery, and probably with backup in mind. So I want to be able to a certain number of restores while not impacting my backups. You can also look at the version. A lot of people will be very conservative when they update their data engine versions. But the hub server and the OC have to be the same version, and so you're missing out on enhancements to the management. Some customers are looking at running a hub server independently. It's not a data protection engine. It's just part of the management infrastructure. So it's very small. It doesn't need to have a lot of horsepower or resources. And that way they can keep more modern versions of the management part and be very conservative with their backup engines. Same thing with the client side. Have currency rules. I can stop having the chaos on client side option sets by using server side. Allow the server side to override. So if someone tries to change a value on the client beyond the standard, they have to go through you and say, how can I do that? We talked about the client management service where you can view the logs inside of the OC. And certainly try to have standardized automated distribution functions. Don't do manual software distribution by click, 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 next, 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 because you're just getting human error in that. Last topic is data spill recoveries. We have the ability to encrypt data at rest. Certainly we've had encrypted tape storage pools for some time, and people have been using things like self-encrypting disk underneath disk-based storage pools. That's a little hard to manage, the self-encrypting disk, because if I need to sanitize the data using cryptographic erase, I've got to do it at the entire storage pool level. So starting in I think it was 8.1.5, we've had encryption at rest for directory container pools. We've had it on cloud container pools. And this gets to be very interesting. So if someone says, look, we've had a data spill. Someone put the social security numbers for every person in a spreadsheet and stored it to the production generally available file server, and you back it up. We've shredded the file on the file server. I need you to sanitize the data in Protect. Well, I can locate where that data is at. I can then move all the other data, delete the inventory object, delete the object from the database, and then I can go out there and move the data from either the container or volume and optionally shred it. Now if you enable encryption at rest, you don't have to shred it. Moving it off deletes the key, and that gets you cryptographic erase. But you can certainly shred it. And things like if it's on a tape drive, once you move the good data off, you use the old-fashioned hammer method. You can certainly break those things up. So there's ways of going out there, and the whole point of this slide is you can do this with Spectrum Protect. It's easier if you use encryption at rest, because then you don't have to worry about going to the OS and shredding files or getting a hammer. Just encrypt it and once the key is deleted, the data is inaccessible. That's the end of this presentation. I hope it was helpful. Thank you very much for your time.